Welcome to Shared Insights, the podcast from BA Insight. My name is Pete Wright, and I'm joined today by BA Insight CTO and Chief Customer Officer Sean Coleman. Hello again, Sean.
Great to always be here, Pete. Good to talk to you.
And founder of Boston-based KMW Technology, enterprise search, big data, and AI services consulting company, and Shared Insights first-timer and member of the BA Insight Advisory Board, Kevin Waters, is with us. Welcome to the show, Kevin.
Thanks, Pete. Pleasure to be here.
Now, we are here to, I should say, I am here to host a conversation between the two of you. And as much as I was trying to position this as a grudge match SmackDown, you'll buy the seat, but you'll only need the edge. Elastic versus SOLR. Is there a right answer to this question? I hope that between the two of you, we can hash out where Elastic and SOLR are in the spectrum of tools. Sean, I'm hoping you can start with how you might approach this question from a high level, and then we have this fantastic expert in Kevin to help us dig into the weeds a bit from there. Does that sound fair?
I think that does. I mean, as Kevin and I were talking over this, I think we had kind of the same idea, maybe that you were alluding to there, Pete, which was, let's do a podcast that's really, hey, which one should I pick, and what's the, which one's better than the other in a SmackDown, and as him and I were talking about it, it gets down to, gosh, it's much more nuanced than that, right? The differences between these, it's not black and white, it's not cut and dry, it's not a definitive answer of this one's better than the other one, but there are some differences, right? Some very specific differences, and I think Kevin's got a great history that will take us through that, but I think my take on it is, and what I hope that people get out of this podcast is, if you are evaluating between the two, what are the things that you should know, right? What are the differences that we would call out, and then from a business perspective, how would that impact you? Why would that matter to you, kind of thing? And that's what I'm hoping to kind of take, and as we get through it, everybody learns something, but. Interested in Kevin and your thought when we started talking about this and your first take on the subject.
Yeah, this is a topic that comes up on pretty much every project that we work on that relates to either SOLR or Elastic, really anything related to search. Because let's just say the juggernaut in the room is the Lucene library itself. And seeing that both Elastic and SOLR are built on top of Lucene, there is definitely a lot of overlap in terms of their technologies, but I think that the two platforms have kind of differentiated themselves in a handful of different ways, and based on those differentiations, you might want to favor one versus the other for your application. And we'll go into some of those things.
How would you discuss the differences on open source between the two?
Both platforms, based on the open source library Lucene, under the Apache 2.0 license, they both are in a way open source in that you can get to the code for them. You can download the code, you can bring it up in your development environment, set breakpoints if you need to, extend it, recompile it yourself, and really both platforms give you that. There is one major difference in terms of the open source aspects of both Elastic and SOLR, though, that should be noted, is that, to my knowledge, the only committers for the Elasticsearch code base work for Elasticsearch. So whereas the code base is open source, it isn't necessarily open for other people to become committers. It's controlled by a commercial entity. In contrast to SOLR, which I think has something like representatives from about 80 different companies, from Bloomberg to Apple, some of the major technology players, and they all contribute, and they all have a sort of much more equal saying on what patches get delivered and committed in, whereas any patches to the Elasticsearch code base have to go through Elasticsearch. So yeah, technically you can say that both of the platforms are open source, but in terms of having an open community, I think that SOLR clearly is a clear winner in this area. I think that most recently at the ElasticCon conference this year, there was a big announcement towards open sourcing XPack, which is a plugin for Elasticsearch. And I think that announcement had some mixed reviews from some of my contemporaries in the industry. in that as much as it is an open source thing, it's still licensed. So yeah, they can call it open source. The code is open, but you're still going to get hit for a license on it, as far as I understand.
Yeah, I think those are good points. I mean, I think when I've talked to other people around, the differences in open source, and I think it's a great point to say, hey, look, from the SOLR side, there's lots of people contributing in that kind of born and bred kind of view of open source, and then on the Elastic side, it is slightly different. And so I think that the advice that I've heard or I've given to others is it really kind of depends on what's important to you as a company. So if you're evaluating these two and you think that we're going to start developing and we're going to build features and we're going to contribute and we're going to see it grow, that may not be what would happen with Elastic. That would definitely potentially could happen with SOLR. But if you're looking for, I want the open source side, so I have access to the code base and to really, get that knowledge of specifically how it works. But maybe you're not as interested into where the commits are coming from, or your ability to contribute at that level. That may be a difference for you to evaluate. So that's kind of what my takeaway on that would be.
Yeah, Sean, so you're exactly right about that. And I think it really brings up a whole category of any enterprise that deals with open source. Anytime you pull an open source project into your internal software, whatever project you're working on, you are always considered downstream development. And anytime you need to make a change upstream, you don't know whether or not that change is going to exist from this release to the next release of that open source project. And one of the things that I've actually found on projects before is that when you are able to contribute your changes back upstream and those become available for you later on, then the cost of maintenance and the cost of ownership of that code goes to zero, which is very often an unaccounted for cost in the product development lifecycle. Yeah, I mean, imagine you have some new awesome feature technology that enables you to, provide better analytics or search, whatever it happens to be. And then all of a sudden it becomes free for you to maintain because the community maintains it for you. Which, of course means that you have good unit tests and stuff. But so long as your unit tests are good, when you push them back upstream, they become part of the core feature set of that technology that you're embracing.
So let's talk a little bit about integrations and API capabilities between the two. Does one offer a leg up in terms of interconnectability with other services?
Yeah, I think that's a good question. And I have to tip my hat to Elasticsearch on this one a little bit. And the reality is that perhaps because Elasticsearch's code base is controlled by a single organization effectively, it has given them latitude to provide a very consistent API, RESTful-based JSON API that kind of allows every interaction with the system to operate in a very similar sort of way. SOLR, by contrast, being an older code base contributed to by a lot more organizations and people, tend to have slightly different flavors for different APIs, and it's not quite as a unified, consistent experience to an end user if you're integrating. Doesn't mean that the features aren't there. It's just the way that you interact with one endpoint in SOLR versus an endpoint in Elastic could semantically be a little bit different. And luckily documentation is there to help you on that. Elasticsearch also has a lot of nice documentation that provides you example like curl commands so you can post or get or delete indexes. Whereas in SOLR, like creating a new collection versus creating an index, creating a new collection in SOLR is kind of a curl command with a bunch of REST parameters that have evolved over time. And Elasticsearch, you posted a body of JSON. Well, if you know the sort of format of that JSON, then it kind of is documenting in a way, and you know that you're making a valid request. Whereas in SOLR, the API will give you feedback if there's an error. I think that the industry is kind of moving more towards these JSON type of requests rather than query parameters on a URL string.
Yeah, and I know one of the things that we've heard, we've been dealing, primarily with Elastic. I think, Kevin, you bring a lot of the experience on the SOLR side. But from Elastic, we've seen, you always deal with an API that's growing up, right? So the API is increasing and it's changing. The backend infrastructures are changing, right? How does that API that you're using in one version maintain to the next version? And I know that there's been some heartache over the version changes on Elastic and the changes in the API, and you did one thing one way and you did something the other. And I believe I've heard, and Kevin, interested in your take, that maybe that's not as often happening on the SOLR side. And what you're interested in what you think about that.
Yeah, that's actually a really good point to bring up. Is that SOLR has had this SOLR J client, the Java-based client for querying and interacting with SOLR and SOLR Cloud. And realistically, I could use a SOLR J client from version like 1.4, 5, 6, 7 years ago, and I could still query a SOLR instance today. Elasticsearch, by contrast, has had probably like 3 or 4 different versions of their client-side API that manage things like adding content or searching a cluster. And I think that there's been, from major release, from like 2.3, 5.0, 6.0, the recommended client-side libraries have changed a few times. So, from that perspective, they've been a lot less stable on a client-side integration perspective. I'm pretty sure that they're actually deprecating the use of some of the older Elastic clients in current versions. So, that's a good example of upstream code changing out from you, so that when you go to upgrade, now you've got to make Java changes or code changes on your client side. Whereas I feel like SOLR has been a little bit more stable and consistent about that from day one.
Yeah. And I think it speaks to the point when I've talked to people about this, it's been, you got to look at everything from every angle, right? So you want to look at it from, with the capabilities that you need, right? You're checking all the boxes, but then, we spoke a little bit, just a second ago around, that kind of hidden cost. Well, the change in an API is a hidden cost, because if it changes on you and you got to go and rework some of your code, you've got that. So that's just one of the things that I would put out there for people, is to take a look at that. I mean, you would expect that as Elastic continues to mature, that probably slows down. I mean, Salesforce.com went through a lot of the same things before they figured out to version their APIs and do some backward compatibility stuff to help people. But something to look at and something to really go, okay, what kind of things have changed, and maybe they're good changes and there's stuff that you want, but it's something to know about.
Definitely a point of contention is really it's the maintenance of it all. You don't want your technology to really change out from you. When you upgrade, you don't want big surprises. And with any software, the more mature it is, the less those changes typically come around. And Elastic is kind of reaching that same point of maturity now, but these are some of the growing pains that people have had with it going through the past few years.
Well, speaking of growing pains, let's talk about core features that have cemented themselves in the two. Are there two core features that really extend the use that you're excited about, one over the other?
So some core features. There are some very common sort of core features that exist in both of them, and this is being able to index and search free text, do relevancy calculations, specify different tokenization based on language detection, or things of those nature. And this is just kind of the bread and butter of search, right? Give me TF-IDF scoring, give me BM25 scoring, whatever relevancy model I have. Let me define a schema or a mapping, depending on whether or not you SOLR or Elasticsearch, to structure my data. These are all like common, pieces of feature between the two. But I think that for a longer time, Elasticsearch has really focused on its feature called aggregators, right? And these aggregators are effectively being able to crunch over all of your data, roll them up into buckets, and give you analytics on those buckets. SOLR calls it a facet, right? So a lot of times when we're talking about features, we could be saying facet, we could say aggregation. Technically speaking, we're really talking about the same feature. And it's a question of what sort of features within facets exist versus what features exist in Elasticsearch's aggregators. Well, Elasticsearch is really kind of, from the get-go, I feel like they've positioned them more as like an analytics engine as compared to a free text search engine. And as a result, their aggregators for a longer period of time have supported things like, sums, averages, min, max, standard deviation calculation on structured data. Whereas SOLR was kind of more in a term-based sort of faceting mode, which works great for like e-commerce scenarios. You're doing a search for TV, you want to see a breakdown of Sony versus Panasonic versus Samsung, whatever it is. I mean, that's what we're really talking about is powering that, we call faceted navigation. Facets and aggregators are effectively the same thing in terms of functionality. When it comes to like flexibility of how you express those aggregators, Elasticsearch has had a more complete API for longer. I don't think it was until version 6.0 of SOLR where Yannick Seeley, the creator of SOLR, added the JSON facet API, which was really an answer to the features that people had in Elasticsearch that were missing at the time for SOLR. And it's kind of a funny thing that you have both of these communities on top of Lucene. You have Elasticsearch and SOLR, and they're actually beginning to compete with each other in terms of features and feature parity. So in a way, they say competition is good for the consumer. I think it's very clear that that's the same case here between SOLR and Elastic.
Yeah, I think those are great points. I mean, I think when one of the things that we see, especially from the use cases of, an enterprise search use case of I've got enterprise data, right? Well, what is enterprise data? The majority of the time, it's text based, right? It's documents, it's things that people have written, it's emails, the things that you want to find, right? And that I think that some of the differences you're pointing out there are kind of the how each engine grew up, right? So I think SOLR really was focused on that text based search from the beginning, while Elastic kind of cut their teeth on Logstash and some of the analysis of there, which the things you point out, the standard deviations, the things are really important there. You're seeing that gap close. I mean, they're both highly viable enterprise search applications, but I think it's interesting, when you look at the differences, when you compare that to kind of where they came from. But yeah, now it's a little back and forth. We've got this, and then SOLR's going to do something that's similar, and then SOLR's got something, Elastic's going to do something that's similar. So you're starting to see that kind of feature parity catch up. But it is interesting to look back at the history and see how those differences kind of came to be.
Both projects are really addressing the community's needs on that. But again, they're even with the graph traversal and the graph plugin for Elastic, they're fitting slightly different use cases, right? One being more like text filtering and search filtering, and the other one being a little bit more exploratory and analytic based, SOLR versus Elastic. So even within the competing feature sets, shall we say, there are still slants, it seems like, where Elastic is more on the BI side of search, whereas SOLR is a little bit more on the traditional text side of search.
Yeah, and I think you hit on something there that I see as kind of the really great thing about the fact that we've got these two open source platforms that are kind of going a little bit toe to toe, right? So neither of them have to spend the time going, how did they do that, right? Because they can just go look and say, oh, that's exactly how they did it. But then they can go, how do we do that in a way that fits our model and talks to our customer base and talks to our strategy, right? So you get this, they both get to benefit from the kind of the rapid, addition of features, but instead of spending the time on building the core of the feature, they get to spend the time on how to really make it fit into their structure and their view of the world, which I think it's kind of the exciting side of this. You don't have an open source person competing with the closed system. You've got two that they got nothing to hide. Everybody can read the code, right? But how are you going to kind of do it differently?
Right. So there are some, places, however, that SOLR has added some features that I don't know that Elasticsearch is ever really going to embrace. And I think probably one of the biggest ones that I'd like to point out is the streaming aggregation framework. And this was committed by, I think, Eric Erickson and Joel Bernstein and a few of the other committers. And effectively what it did is it turned SOLR into a full-blown MapReduce framework. So in a way, those guys in the community are actually taking SOLR a little bit closer to like the big data, map reduce sort of environment. And I don't see the same sort of thing happening on the Elastic side. And maybe that's just because I haven't, heard a press release or something about it. I'm sure they're thinking about it. But one of the interesting things on the SOLR side that this allowed for was a proper JDBC device driver for SOLR. So for developers that actually want to query SOLR from their code exactly as they would query a database, they can do it, right? And I think it's really only in the most recent release, or like 6.3 of Elastic, that they're starting to talk about supporting this a JDBC driver. So again, it's one of the things like, oh, this community had it first, and then that one gets it, and vice versa. But some of the things that I'm seeing coming up in the streaming aggregation framework, in addition to supporting full-blown SQL and JDBC support, is a lot of machine learning that's actually built on top of the index itself. And I think that's really exciting stuff. And a lot of the numerical analysis, statistical analysis, and time series analysis that's coming from the streaming aggregation framework. I mean, you would never think of SOLR as a platform that allows you to do large-scale Fourier transforms, but now it does. Like these are things that were relegated to like digital signal processors, and now we're starting to see features, looking for aliens, SETI at home, whatever it is, showing up in search engines themselves. And I haven't seen Elasticsearch's answer to that yet.
Yeah, I think, and we've spoken a lot, Pete and others on this podcast around, AI, machine learning. We actually, Jeff Fried and I just finished one not too long ago. But I think that one of the things that we've been seeing a lot of, and I think both, anyone who's looking at implementing a search engine needs to understand that there's actually an additional set of value here, that once you get all this data in the place, your ability to implement machine learning and to integrate with some of the AI capabilities out there, Google or Microsoft, what they're doing, a lot of those take a lot of big data sets, and a search engine gives you a way to manage and access that data set. So don't forget that either way you go, there is some benefit here, and what you'll start seeing with both what they do internally with machine learning, and then what you can do now that you've aggregated all that data into your index to then go and leverage into any of your kind of AI or ML based applications. I think is a great benefit for anybody, and they should know about that.
For certain. I mean, actually, if you look at the explosion of people building and training and using in production neural networks and deep neural networks, the number one problem that you always have with those networks, as a matter of fact, is the exact same number one problem that enterprises have primarily solved with their search engine technology right now, right? In that, at the end of the day, in order to get good relevancy out of your search engine, you want to make sure that all of your data gets indexed in a way that's relatively consistent. The data is pretty well formatted and normalized, or denormalized, shall I say, and available for querying. Well, as a matter of fact, if you look at the input and output layers of neural networks, they look for that relatively well-formatted data coming in. So all of that investment that enterprises have made over the past, 20, 30 years in their search infrastructure and all the ETL that goes into that, well, effectively, that's the same sort of infrastructure that needs to be in place to really train and take advantage of, the advances in artificial intelligence and deep learning that are occurring now. So there's a huge amount of overlap.
You guys, I'm worried that after this whole conversation, neither of you are going to commit to picking a winner.
You don't think? Well, I think I have one that to me, I don't think there's a great answer one way or the other, but I do have one area that I think that one is a kind of a winner of the other. I'm interested in what Kevin thinks, but as I look at it, there's certainly the code based aspect of this, but let's flip it and talk about the maintainability, or what we'll call DevOps, right? So development, somebody's got to spin this up, somebody's got to put the servers behind it, right? And I think that from what I'm seeing or what I'm hearing, the Elastic side's kind of winning that battle, and it probably stems from the fact that they're actually operating a business running it, right? So they've got to make it so they can manage it, right? So their ability, from the manageability, ease of installation, kind of troubleshooting what's it using on my disk, what's it doing on memory, what's garbage collection doing, statistics, all of that. Elastic's got a lot of stuff there that makes it, from a DevOps perspective, pretty easy to run. I don't have a lot of experience on the SOLR side. I know they have some metrics API and some stuff that's coming up, but interesting. Is what I'm seeing there right, Kevin? Do you think the same thing? Are they winning the DevOps battle on the Elastic side?
They're definitely duking it out, and for certain, like Elasticsearch has been kind of from the get-go always really intended to be very cloud-centric with a cloud manager and all that sort of stuff. And if you look back at the essence of SOLR, it was server on Lucene with replication, right? So it did, and it was kind of a very fixed sort of structured environment where you had a bunch of shards across servers and a defined set of replicas. Elastic kind of took a much more dynamic approach to that from day one, where adding machines or removing machines from the cluster was managed through their consistent set of APIs, right? They have their cluster APIs, node APIs, all that stuff in Elastic. Whereas it wasn't until about version 6.0 of SOLR, a little bit later than 6.0, where the collection API really kind of came into its own. So I think probably SOLR historically has lagged behind in some of those operational aspects. They're getting better, but still not necessarily closing the gap 100% on Elasticsearch. Two more things that I'd actually like to bring up on that. The first one you mentioned about the code base, and there are a handful of places in SOLR that it really just kind of feels like some of the code, although it works and is very efficient, is a little bit convoluted in some places. One example historically has probably been around hit highlighting. Whereas in Elasticsearch, I feel like it probably had better architectural governance on the code that was put together for that. So maybe some of the code is a little bit cleaner and more maintainable there. And then the last sort of point that I'd like to point out is that there's a sort of a learning curve. And I think that the learning curve is what really made Elasticsearch get adopted as much as it has. Because not to say that it's brain dead simple, but to do a very simple application, Elasticsearch from day one has made it, let me just download the software, let me start up the server, don't even have to think about anything. I'll just hit the Elastic index or Elasticserver, create an index, and start pumping data in, and it magically figures out what my schema is. We'll go into that. But the barrier to entry there, the learning curve, is very flat. It's very simple for people to get started. Now, as soon as you wanted to go deeper than that, it begins getting very difficult. But for the very simple, get something up and running, build a POC, Elasticsearch is just way easier. The learning curve on SOLR, a little bit steeper in the beginning, but you reap the benefits because you are already deeper into the technology and you will end up understanding it more. It might be like, this is kind of an interesting analogy that kind of came to me, is that, maybe Elasticsearch is a little bit more like the Apple sort of mentality. Don't make me think, just make it work. Whereas SOLR might be a little bit more about the Android sort of approach, where you're exposed to a lot of those details.
I think that's a great point. I mean, I think when you think about certainly the adoption of Elastic is huge, right? So you see it, and I think you make a great point, which, I mean, a lot of the adoption. So you have people that are building applications, and someone says, hey, you got to have search in this, and they're like, I don't want to work on that. I'm working on this, right? I'm building whatever next great thing that I've got, and I'm solving all these problems. And Elastic does make it easy for you to put something in, and you're going to get, if your search requirements are very, just make sure I can search the data that I put in and give somebody back some pretty decent relevancy. Yeah, you probably can do that pretty fast. But I think you make a great point, and I've heard it described as, if you have very specific and nuanced kind of relevancy requirements about how the system needs to handle certain bits of data, and you really need to get in there on that level, that SOLR is going to help you do that a little bit faster. While if you have a kind of the more generic, I need to provide search capability, I'm a app shop, and I'm rolling this thing out, and I just can't roll it out without search. But it's a secondary, and I don't want to minimize it in any way, that may be one of the initial decision factors for someone to make.
Yeah, I mean, cost, timeline for delivery, whether or not you have engineers that are available to help you one way or the other, can really help influence your decision on which technology to go for, right?
You made a comment, Kevin, about schemas. Do you want to talk a little bit about schemaless and why that's a relevant topic for us here?
So good segue, right? So from day one, Elasticsearch is always touted being completely schemaless and don't even have to worry about it. Just automagically determines what the structure of your data is and should be. And SOLR has always kind of enforced that you have a schema, and you define, here are the fields, here are the types of fields, this is a string, this is a general text field, this is a date, this is a number. SOLR also had the concept of a dynamic field, so you could use like wildcards on your field names, anything star dot or star underscore s would be indexed as a string, or star underscore d as a date, for example. So you did have some concept of a dynamic schema in SOLR, but it wasn't nearly as freeform as what Elastic has from the get-go, saying, like, other than a document ID, do whatever you want. It's kind of the idea. And I think that this was really enticing to people until they actually started using it. And I think that what ended up happening, and people started realizing this, is that Elastic would make the wrong decision sometimes about what data type was in a particular field. And forever, from that point forward in your index, you are stuck with that wrong decision. And that's been a pain sticking point. So what ends up happening? People ultimately end up defining a schema, or as they call it in Elastic, a mapping. So I remember a lot of the times when we talk about features, one versus the other, it's just a matter of vocabulary. SOLR calls it a schema, Elastic calls it a mapping. So by Elastic having a mapping, sure, it's schemaless. It doesn't have a schema, it has a mapping. Well, between us all, it's the same thing. But there are some pretty big differences between Elastic's mappings and SOLR's schema, in that Elastic allows you to specify a set of fields and their types, a schema, per object type in the index. And this was nice because if you wanted to index a lot of different, like fundamentally different types of objects in your index, Elastic allows you to specify a schema or a mapping per object type in the index. And this was a feature that I think a lot of people liked, and it meant that the job of data provenance and governance of specifying and defining your schemas was just a lot more freeform in Elasticsearch as opposed to SOLR. Well, to my shock, fairly recently, Elasticsearch discovered that having schemas per type in their mapping has been problematic, and I believe that they're moving away from supporting that. So I believe support for that is going away in a future version of Elasticsearch. And somebody can double check and maybe reach out to me and tell me if I'm completely wrong about that. But recently we were looking at some upgrades of Elasticsearch, and we pretty heavily relied on this mapping per type concepts, and to discover that Elasticsearch is abandoning that is kind of an interesting thing. It doesn't necessarily say that Elastic went out in the wrong direction to start with, but they are aligning with more of a SOLR convention for how the index is laid out. I thought that was kind of an interesting.
Yeah, I think it's a funny point, and I think back to when I agree, right? So the schemaless and what Elastic touted. It's always funny though. I've never had a lot of success looking at developers and going, "Don't worry, the system's just going to do it for you. You don't have to worry about it." They tend to look at me a little skeptical when I say that. They're very, very questioning, right? They're like, "Are you sure?"
Right. Sure, for a POC, makes perfect sense. Don't care about it. Just slam some stuff in, make some rapid changes. But as soon as you actually care about like fine tuning anything, maybe it's you want to run an aggregation on a field, so you want to have it not analyzed or not tokenized versus another field that you want free text on, or if you want to do sorting on it, is it going to be a case insensitive sort? Does a blank value show up at the beginning or the end? All of a sudden, now you have to deal with these semantics and details. So I guess it's that sort of that barrier to entry. It's like, cool. You get in very quick. You can get your data in. You can start seeing some results coming back very quickly. But almost immediately, you're going to have to go in and tune that mapping or schema.
Well, gents, as we get to wrapping up here, I hope that as listeners, you may find our Elastic versus SOLR Smackdown unsatisfactorily lacking in a clear victor. But I hope you find that this deeper dive is illustrative of some of the key issues that can help define your development decisions. Sean and Kevin, thank you very much for your help today.
Great. Happy to be here.
Pete, thank you so much. I had a great time chatting about this.
For those who are listening and have made it all the way to the end here, are there any key resources that you recommend, key assets that help you to, make your own decisions in this area that we can put in the links in the show notes? Where would you like to point people?
Yeah, that's a good question. Usually I say, use the source, Luke. That's always a good resource. One that I will call out right now is what the community more or less has been maintaining and contributing to on Lucine's side, and there is a website, SOLR-elastic.com, and generally speaking, the community kind of keeps that up to date, and it really is this sort of like head-to-head feature comparison. So if you want that like bullet list, report card between the two of them, I would take a look at SOLR-elasticsearch.com.
That is a great resource, and I'll add to it. And I will say, I think we can be definitive in one way here, Pete, which is there are a couple of clues that maybe would tell you to go one way or the other, but they're not what you think, right? If you're all Java developers, only Java, and you already use things like Zookeeper, well, probably tend to SOLR. If you're Ruby, PHP, and you live and breathe JSON, maybe you want to go Elastic. If you're somewhere in the middle, listen to the whole podcast and make your own call.
I think that's a very, very apt breakdown of it.
Outstanding. And Kevin, as a first-timer, where would you like to point people to learn more about you and your work?
Sure. So by all means, take a look at KMWLLC.com. That's our consulting company. We've been doing search stuff for 8 years together. Prior to that, I was at Ativio, and prior to that, senior architect at Fast Search and Transfer, for those people who've been around that long. So always happy to talk search, technology, AI, data integration, or even if you want to talk about robots, let's talk about that too.
Oh, outstanding. Thank you. Again, Kevin Waters, appreciate your time and attention today. And thank you, everybody who has downloaded and has listened to this show. We appreciate you. We appreciate you coming back to us week after week and learning more about search, intelligent search, and all these fantastic topics. On behalf of Kevin Waters, and our wonderful regular contributor, Sean Coleman, I'm Pete Wright. We'll catch you next time right here on Shared Insights, the podcast from BA Insight.